Sixth grade, going to get distinguished today with two variable equations. We're going to make sure we can relate all the different ways we represent them. So make this the next title on your next 3 page in your math notebook, and then give me your full concentration. I'm going to warn you, I may have to go fast today, so be ready to pause and be ready to really concentrate because it's kind of a lot here. And I got my 15-minute limit, so be ready. So far we've always kind of started anything we did with two variable equations where I gave you like a sentence, like this one, Jamie is 2 inches taller than Katie. And from there we wrote the equation for it. So like for this one I would say if Jamie is 2 inches taller than Katie, Katie is shorter, so Katie's height plus 2 equals Jamie's height. And then we made, from there we could make a table. Katie, Jamie. If Katie is, I don't know, reasonable heights to say, if Katie's like 30 inches tall, Jamie would be 32 inches tall. If Katie is 35 inches tall, Jamie would be 37 inches tall. And then we could take these values and make a graph from those, which I'm not going to do on this Connect to save you time because I'm going to do it a lot in the lesson. And so we took this same idea and we had 1, 2, 3, 4 different ways to represent the same relationship between these two variables, Katie's height and Jamie's height. We could do it with words, we could do it with an equation, we could do it with a table, and we could do it with a graph. And all 4 of these representations started with the same thing, and we can move between them. So what I want to focus on today is, well, what if we don't start here? I want you to be able to take any one of these 4 ways to represent a situation and be able to make the other 3. So let's look at one where we start with the graph, why don't we? So it says this graph shows the relationship between the number of laps L, I'm going to make it a capital L because lowercase l is a bad variable because it looks like a 1. This graph shows the relationship between the number of laps around a park that Tamika runs and the number of miles for her total run. And here's the graph. So pause for a moment, look at the graph, and try to get a handle on what is going on. So when I start with a graph, I like to almost go in backwards order. I like the easiest thing for me to do with a graph. It is very hard for me to turn a graph into words. It is very hard for me to turn a graph into an equation. For now, you'll learn how to do that in probably 8th or 9th grade very quickly. But for the time being, it's very easy to turn a graph into a table. So if I want to do the other 3, I'm going to jump right to the table. So laps is my independent variable. The number of miles depends on the number of laps. Makes more sense than the number of laps depends on the miles. This is my independent. This is my dependent. So that's usually on the horizontal and dependent's usually on the vertical. So I'm going to put laps over here and miles over here. And let's check my points. So 0 laps, 0 miles. 1 lap looks like 1, 2, 3, 1/3 of a mile. 2 laps, 2/3 of a mile. 3 laps, 1 mile, and so on. So it's very fast and easy to turn a graph into a table, so I like to go in that order. If I get a graph, the first thing I make is a table. And then if I keep going backwards, it's not too hard to turn a table into an equation. It is not easy, but it's not so bad. So I'm looking for how am I getting from here to here every single time? And what I notice is each one lap is 1/3 of a mile. So the number of miles, dependent variable, is equal to the number of laps times 1/3. 1/3 times 1 is 1/3. 1/3 times 2 is 2/3. 1/3 times 3 is 1. I'm always taking this laps number and multiplying it by 1/3 to get the miles. So every time, no matter what the miles are, I take the laps and I multiply by 1/3. So it's my equation. And then all I have to do is take that idea and turn it into words. So what I'm noticing is each time she runs one lap is 1/3 of a mile. That's what I'm noticing. So I'm just going to write something like Tamika. I'm going to type it because I'm faster at typing. Each lap Tamika runs at the park is 1/3 of a mile, something like that. And now I've got all 4 representations starting from my graph. Would have been really hard for me to go from my graph straight to here, or from my graph straight to here, but it was not so hard to go from my graph to the table and back. Let's do another I do, and then we'll try a we do together. Possibly 2, but I don't know if I'll make it. All right, so I'm going to this time start with an equation and then try to make the other 2 from the equation. So it says this equation shows the relationship between the number of hours that Timothy babysits and the amount of money that he makes. So M equals 5 times H. So when I start with an equation, it is tough. You don't yet know how to go straight from an equation to a graph, but you do know how to go from an equation to a table. Make a little bigger line. And from a table to a graph. So I'm probably going to go in that order, and I might do the words last. Maybe not. You know, this already, you might want to do your words first if that helps. I'm going to do the numbers first, and then once I've seen the numbers 3 ways, I can come up with the words easier, I think. So if you remember, when we make the tables, you don't have to do this, but I like to put the independent variable on the left and the dependent variable on the right. That's what you're going to see in the future, so I like to get used to doing that. So let's figure out what's what. Hours and money. Oh, money is M, sorry. So does the number of hours he works depend on the amount of money he makes, or does the amount of money he makes depend on the number of hours he works? That second one sounds better. So money is the dependent variable, and hours is the independent variable. So here we go. M equals 5 times H. I like to do 0 for my independent. I like to test it out. You may forget that, and it's okay if you do, but I like to do it. So if he works 0 hours, 5 times 0 hours would be 0 money. Makes sense. If he works 1 hour, 5 times 1 hour is $5. If he babysits 2 hours, 5 times 2 hours is $10. If he works 3 hours, 5 times 3 hours is $15. And that's enough. 3-4 entries is usually enough. I am ready to turn this into a graph pretty easily. Again, remember, independent variables, they go on the left in your table, and they go on the horizontal axis on your graph. So as I make my axes, I put my independent variable horizontally. That is hours babysat. And this is money earned. Money. And I need a scale. Let's see. Looks like 5, 10, 15. I'm going to do my hours by ones. 0 hours goes right where the other axis hits here. 1 hour goes on this line. 2 hours goes on this line. 3 hours. 4, 5, 6, 7. And money goes by 5, so it's kind of easy sometimes if I notice that pattern. You don't have to go by 5s, but it can be easy to go by 5s. So I probably just will here. 5, 10, 15, 20, and so on. So no hours, no money. 1 hour, $5. 2 hours, $10. 3 hours, $15. And now, got my line, and my graph's complete. So last thing to do is just to kind of put that situation into words. So as I see here, each hour that Timothy works, he makes $5. So I can even word that as a unit rate. Here, I would just probably say Timothy earns $5 per hour babysitting. Or for each hour that he babysits, or something like that. Okay, so that's how we kind of take one and make all 4. I have 2 we do's set up. I don't know that I'll get through them both, so we'll try, or I may have to set you out on part of the we do on your own. So pause now. There's going to be a lot to write down before you even start. So here's going to be our first we do. I'm going to ask you to write down the situation and the graph, which may take you a second, and then unpause and we'll work it through together. So it says this graph shows the relationship between Caitlin's age and her younger sister Malia's age. And I started with a graph. So when I start with a graph, for me and for now, the quickest thing to do is to go to the table first. There will come a time when you learn how to take a graph and write an equation from it, but that's down the road and not as important quite yet. So another way to represent this graph is with a table. So Caitlin's age is on the bottom, so they're using that as an independent variable. So I'll put it on the left. Malia's age is the dependent variable, and it goes there. So let's see. So let's make sure I read this correctly. When Caitlin's age, no, I'm backwards here. I might have made this graph backwards. Hang on, I'm going to pause and look at it. I may have to change it. No, I did it right. I'm okay. So what I see here, when Caitlin's age is 4, Malia's age is 0. When Caitlin's age is 5, Malia's age is 1. When Caitlin's age is 6, Malia's age is 2. Caitlin is 7, Malia is 3. And when Caitlin is 8, Malia is 4. I ran out of space. So there's my table for the situation. So now I go up to my equation. I say, okay, how do I relate these two ages with an equation? So as I look here, it's like, how do I go from here to here, or how do I go from here to here, one to the other? So it looks to me like I always either subtract 4 from Caitlin's age. 4 minus 4 is 0, 5 minus 4 is 1, 6 minus 4 is 2. Or in vice versa, I could take Malia's age and add 4. Doesn't really matter which way you do it. Malia plus 4 is Caitlin. Malia plus 4 is Caitlin. Malia plus 4 is Caitlin. So I can write Malia plus 4 always gives me Caitlin's age. Or I can do Caitlin's age, subtract 4, always gives me Malia's age. And again, I know I'm going very fast, so if you need to pause or rewind to think this through, please do. I'm just going fast because I have a firm time limit that I'm approaching. All right, so that's the last thing. So when I look here, I just need some way to put this into words. So Caitlin is older and Malia is younger in this case, and it's always by a difference of 4 years. So I can word that one of two ways. I could just say Caitlin is 4 years older than Malia. Or vice versa, I could say Malia is 4 years younger than Caitlin. Doesn't really matter which. Those both mean the same thing. So now I have taken one situation, one representation of this situation, and made it into the other 3. So hopefully what I really want is in the end for you to understand all 4 of these ways of looking at this say the same thing. They just say it in different ways. We can talk about this situation in words. We can talk about this situation with equations. We can talk about this situation with a table. And we can talk about this situation with a graph. And they all just are 4 ways of showing the relationship between these 2 variables, Malia's age and Caitlin's age. I'm not going to try to blast through another we do. I think it'll take a little too long. I was going to give you a we do where we start with the equation and go to the words in the table. So I'll show it to you. If you have time to pause here and work this through on your own as practice, I think it would be beneficial before you get here tomorrow. But I don't have time to go through it all with a recording for you without just like super rushing. So I'm going to stop there. So this was a doozy of a lesson, and it is a distinguished topic for 6th grade math. Being able to look at all 4 ways of showing a 2-variable equation and knowing that they're the same thing. So if it was a doozy for you, and especially since I went so fast, if you need to go back and look at any of the examples again, please do. You can always rewind and listen again and hopefully get a handle on this very distinguished and challenging skill. See you tomorrow, everybody.